Yeah. Keep going here. I said you need to know this stuff because this is the very basics of all algebra, especially algebra 2. We've been going over this type of stuff. You'll learn some tricks for algebra 2 factoring, but right now you need to understand why. So use factoring to solve this equation. All right. So this is the same thing. We're going to move this over here. So we're just going to do that by subtracting. Okay, and now that's equal to 0. Now we see this is common and this is common, so we're going to factor that out, and which leaves us with 2x minus 3 minus, bring that down, x plus 1. Excuse me. And close that parentheses. And that's all still equal to 0. Now, we can do this. We're going to distribute this negative right here to this term and this term. So we're going to have 2x minus 3 minus x minus 1. X minus 2. Now I can combine like terms. That gives me 2x minus x is x. Negative 3 negative 1 is negative 4. So now I have x minus 2 times x minus 4 equal to 0. And I set both of those equal to 0. X equals 2. X equals 4. There's my answers. Now, think about it. If I take this x equals 2 and plug it in, that gives me 0. Well, 0 times anything is going to be 0. And if I plug in the 2 right here, that gives me 0 again. So that's going to equal 0. 0 equals 0. And 4 also works. Okay, if you were to plug that in, each side of that equation would equal each other. Now let's do this again. Solve each for x. So minus 2 minus 2, x equals 3. What about here? Subtract 2x, subtract 2x. X squared is equal to 3x. Now, how am I going to do that? Well, I'm going to set it equal to 0. So let's subtract 3x, subtract 3x. I have x squared minus 3x equals 0. I have x in common, so I'm going to factor that out. Leaves me with x minus 3 equals 0. So x equals 0 and x equals 3. Because I'm going to set both of these equal to 0. Okay. All right. Let's see here. Okay. Now, don't let this one scare you. We're going to set it equal to 0, which just means to move this over here by subtracting, right? So that leaves me, I'm just rewriting this first part. Minus, because we're moving it to the other side. Now it's equal to 0. Now, here we have 5x minus 20, 5x minus 20, 5x minus 20. So we're going to factor that out. And we'll say 5x minus 20. Okay. Now, if I was to divide this whole thing by 5x minus 20, that cancels and leaves me with x. Same thing here. Divide by 5x minus 20 because I factored it out. That leaves me with plus 2. And the same thing right here leaves me with, oh, sorry, didn't want to do that, minus 5. And so if I was to distribute that, that's what I would get. Okay, that's all equal to 0. Now I can do this, x minus 3, right? I combine those terms, I get x minus 3. And I still have my 5x minus 20. So let's solve. 5x minus 20 equal to 0. Add 20. 5x equals 20. Divide by 5, and I would get x equals 4. Set x minus 3 equal to 0, and I get x equals 3. There's my two answers. Oh, here we go. Here is what we call the difference of two squares that equals conjugates. Or in other words, we're just going to fool this. If I fool this, first is a squared. Outer is going to be a positive 5a. The inner is a negative 5a. And the last is negative 25. Well, 5a minus 5a cancels and just leaves me with a squared minus 25. So conjugates are going to always, always, always cancel that middle term and leave you with the difference of two squares. A squared, and this would be a squared, and then the 25 would be 5 squared, and the difference of those two squares. Okay, so the same thing right here. Now, instead of doing 88 times 88, they just said 88 squared, right? Because if you were to do that, you would get x squared minus 88x plus 88x plus 88 squared. And I don't want to do that. That's really big. These cancel and leave me with the difference of 88 squared. Oh, that should be a negative, not a positive. So here is once x and 88, they're squares, and we're finding the difference of those. So those are difference of two squares. That's a little trick that we know. Okay, so a squared minus b squared equals a minus b. Yeah, because we know what? How can we prove that? Well, this is a times a times a minus b times b, right? Well, what do both of these have in common? Both of them have what? An a and a b, right? So we could factor that out and say a, and you could do plus b or minus b, it doesn't matter. So a minus b. Well, if I already do that, let's call this the plus b. What's left? I have a minus b. Okay. Now let's do this. Okay. So we see this right here, and hopefully you see that and you go, okay, that's going to be the difference of two squares. It's the subtraction, so it's the difference. And I know that 3 is a perfect square of, 9 is a perfect square of 3. So what I'm going to do is I'm going to say x minus 3 times x plus 3. And that's going to equal 5 times x minus 3. Now we would subtract and get a negative 5x minus 3. And x minus 3, x plus 3. And we have two common terms, x minus 3, so that's going to be x minus 3 times x plus 3 minus 5 equals 0. And I'm going to, let's move. Okay, I'm going to rewrite this. I'm going to do the next step and combine these like terms, but I'm going to do it up here. Okay, x minus 3 times x minus 2. So x equals 3, x equals 2. All right, same thing right here, difference of two squares. This is going to equal x minus 2 times x plus 2, right? And then that's going to be equal to, I've done x's and those are w's, sorry. W plus 2, w minus 5. W. Okay, now if I move this to the other side, okay, I have W, let me draw a line right here, make sure this is different. W plus 2 times W minus 5 minus W minus 2, W plus 2 equals 0. Now I have two common terms. W minus 2, so we'll factor that out. And that's going to leave me with W minus 5 minus W minus 2. Go ahead and do minus W plus 2. And the W's will actually cancel. And that leaves you with a negative 3. So W plus 2 times a negative 3. Just trying to make sure I did this correctly right quick before we go any further. Okay, so that's going to give us negative 3W. If I distribute that, because we can go ahead and do that, minus 6 equals 0. That's negative 3W is equal to 6. Divide by negative 3, divide by negative 3. W equals a negative 2. And that would be your only answer. That's the only one that's going to work, I believe, if I did that correctly. All right, let's look at 14. A string 60 inches long was being laid on a tabletop to make a rectangle of perimeter of 60 inches. Okay, write the width of the rectangle as 15 plus x inches. What is the expression for the length? What is the expression for its area and what base? Okay, so if if this is the width, okay, the length would be what? Oops, sorry, I was trying to get something off my screen there. Okay. We need 60, right? 60 inches. Well, this would be 60 minus what? The 60 minus 2. Well, sorry. 15 plus x, because that's 2 of our width, minus what? 2 of our 15 plus x's, right? 60 is equal to, okay, so hold up before we do that. This would equal what? That would be 0 for our perimeter, right? This is our 2 width. This is our 2 length. Nope. That is not correct. Hold on one second. Gotta make sure I got all my terms here. I need to do this right here first. Okay. So our width is 15 plus x. Our length right here would be 60 minus 2 of those. And then all that would have to be divided by 2, right? Because I'm going to have 2 of them. Okay. Now, the expression for the length would be this. That's the expression for the length. Okay. Hold on one second. Okay. Sorry about that. I had a bunch of messages coming through. I need to simplify this for y'all. Let's try and make it as simple as possible. Okay, let's do this. We're going to actually draw this out. Okay, let's call, okay, the length is actually 15 plus x. Okay, so let's think of that as breaking this up as to 15 plus x. Well, what does that mean the length is going to be then? So if I was to draw this right here, what is that going to be? This would be 15 minus x, right? We could do that because we know that 15 plus x times 15 minus x is going to give us, nope, that's going to be the perimeter, 15 plus x plus 15 minus x has got to equal 60 for it to be the perimeter. So what we could do is say this is what? If we do distributive property here, if we fold this, we're going to have 15 squared right? X squared minus 15 squared. So these are conjugates. And we have the difference of those. What else? What is an expression for the area? Oh, well, that's the expression for the area. You don't actually have to do it. This is area. This is the length. And let's see here. What's the value of the X of the area of the largest possible value? Well, if we take out this X here and we make it 0, we have a 15 by 15. Because here it's going to have to be subtracted, and that's not going to help us out any. So if we make that be a 0, we have a 15 by 15. So 15 squared is probably going to be the biggest you're going to be able to get it. It'll be a square. That was a tough one. A lot of thinking going on in that one. I'm surprised that was an example. Surely there's not going to be one like that for your homework. Okay, so the zero product property says that if AB is equal to 0, then either A or B is equal to 0. It's what we've been saying. Okay, as long as one of the factors is 0, then the zero product property tells us that the whole thing is equal to 0. All right. I'm going to look through your homework and see if there's any that I don't want you to do, and I'll post it on here as well. That should have it all.